Hi everybody, welcome back to AI in the Woods. In the last video we were talking about meaning and the reason why meaning is important for the development of AI systems. So in this video I will come back to this notion and talk a bit more about what meaning is, especially in humans. So meaning is the glue between the words and sentences in our languages. English, Chinese, Japanese, and so on, and worlds. Why do I say worlds in the plural and not the world? Well, because we humans spend considerable amount of time talking about things that are not here and now. Think of all the times that you talk about what happened yesterday, what will happen tomorrow, what you wish for tomorrow, the way things should be or could be. Every time that you use one of those little words, might, could, should, will, or the past tense, you're actually referring to a state of affairs that you're not able to point at. I cannot point at things in the past, they're not here anymore. I cannot point at things in the future, they're not here yet. Natural languages have got that magic in them that they actually let us express to another person the state of the world or the state of a world as it could be. So imagine that I say to you, if only I had a space shuttle, I would spend my holidays on the moon. You understand this sentence perfectly. Now, I don't have a space shuttle. I don't know how to fly to the moon. And I don't really know what a holiday would look like on the moon. And still you've understood my sentence. You understood my sentence because you know very well what a space shuttle is, what the moon is, and what kind of sequence of events a holiday is. You can in fact infer things from this. You know that when I'm on the moon with my space shuttle, I probably won't work because it's my holiday. So a lot of complex things are happening. Here I'm referring to something which is just inside my head. I've got that picture of me on the moon and I'm able to convey it to you even though it doesn't exist. Now this ability to talk and refer to things in the world and in other worlds is a hallmark of human intelligence. That's what allows us to plan. Say we want to bake a cake for our friend Mary, who's visiting tomorrow. And I say, what chocolate shall we use? Shall we do a milk chocolate cake or a dark chocolate cake? And maybe you'll say, no, Mary doesn't like dark chocolate, so let's go for the milk chocolate. Now we've gone through something very complex here. We have used a fact about Mary in the real world, a fact that is fairly constant about Mary. She doesn't like dark chocolate. And using this fact, we've made a decision about something that has not yet happened, about something that will happen tomorrow. We don't have a cake yet. We are not even maybe in the kitchen. We haven't bought chocolate. And still we're already planning for the future. And that's something that humans do very well, and that requires that ability to think about something that doesn't exist yet. Now think of AI systems. If you want them to plan, if you want them to be able to create new things, they will have to have that ability. Now that's really hard to acquire. To some extent, the AI systems that we have now have made some progress towards processing language itself. They kind of know what to do with words, and that's why you see all those fantastic looking texts generated automatically by AI systems. They still don't really know what's out there in the world, let alone what's out there in other worlds that humans only have inside their heads. And that's going to be a crucial ability to acquire if we want them to become creative minds and planning minds in the way that we are. Now, how we get there is actually really hard. And the first hurdle is about being able to represent a world inside the mind of a machine. Now, if you remember at the beginning of this video, I said that meaning is a formal notion. What does it mean? It means that you can actually translate meaning, this correspondence between what we have in our head and what is in worlds, the real one or others, into some kind of mathematical notation. Now, why is this important? Because if you can translate things into maths, then you can put them inside the mind of a machine. Translating worlds and the correspondence between natural languages and worlds is something that linguistics has been busy with for many decades now. And we're now making progress using those logical notations, those mathematical notations, in a way that possibly one day I can pack this whole forest around me into a bunch of numbers that I can feed to a computer. This is hard. It requires having notions of concepts. What is a tree? It requires to have notions of entities. This tree here is not that tree here. I can count them. It requires having notion of events. What does it mean to walk, to move? What does it mean to speak? What are things that go in a sequence? Like, I'm going to go home now. So what does it mean to go home? And what does the sequence look like? We need to translate all this into numbers and store them in an efficient and appropriate way inside those AI systems. That's a tall order. And in some next videos, I will explain a bit more how this translation takes place and why it is so hard to actually achieve it. But for today, I will leave you with a message that that correspondence between concepts, language, and the world is really important. That it can be formalized, it can be put into numbers, and that we're still long way away from machines having planning and creative abilities because they don't know about worlds.